Good morning, Year 7. Welcome to Lesson 4, which is boiling and other changes of state. To start off, please, can you write the title and underline it, and write today's date and underline it as well. I'm going to read you out our lesson objectives today. I would like you to rate each one of these red, amber or green, depending on how you feel about them at this moment in time, and then we will revisit them at the end of the lesson and see if you have made progress. So number 1 is use the particle model to explain boiling. Number 2 is to state the temperature at which water boils. And number 3 is we're going to identify other changes of state. While you're writing, you may want to have a think about this riddle today. Many have heard it, but nobody has ever seen it. It will not speak back until spoken to. What is it? And for a hint, think back to your last topic that you did in science. It will not speak back until spoken to. Pause the video if you want to have some thinking time. Right, did you get it? If you said it is an echo, you are absolutely right, because it doesn't speak back until it's spoken to. Okay, we're going to start with a little recap. We've got our 3 states of matter here, solid, liquid and gas, and there are some phrases around them. I would like you to match the phrase to the correct state of matter. Pause the video and have a go at this. Match them to the correct state of matter. How did you get on? Here's what you should have had. For a solid, it has a regular formation. That means the particles are all in that regular pattern you see there. Solids don't take the shape of the container that they are in, and the particles vibrate in place. Liquids do take the shape of the container that they're in, and the particles slide over one another. And for gases, they also take the shape of the container they're in, and they are freely moving and colliding. See how you got on, make any corrections that you need to. Okay, today our first focus is on boiling. So the first thing I'd like you to think about is what happens to the particles in water when water boils. Last lesson, we looked at what happens to the particles when something freezes. So what about when something boils? I'd like you to have a think and just jot down just maybe a sentence or two of your first idea here. Pause the video and do that now. Okay, at this stage, I don't want you to write any of this down. I want you to just have a little look at this and see how close your original thought was to this process. So what happens is water is heated, and because it gets heated, the temperature rises. Because the temperature rises in the water, the particles gain more kinetic energy. You're giving them heat energy by heating them up, and that heat energy then gets converted into kinetic energy and they start moving more. And some of them then have enough energy to move away and become gas particles. That is what happens in boiling. I don't want you to write this down. Just keep watching. Now it's your turn. I would like you to read these sentences and put them in the correct order. Based on what you just saw about what happens to particles when they boil, you should be able to put these in the right order. Write them down in full. These are going to be your notes. Pause the video now and have a go. Okay, how did you get on? This is the correct order. Have a look at how many you got in the right place and make any corrections that you need to, because these are your notes about particles boiling. So it should be, at room temperature, water particles can move past one another freely, because remember they're a liquid, so they're sliding over each other. When water is heated, the water temperature begins to rise. This causes the water particles to gain kinetic energy. After heating for some time, the temperature of the water reaches 100 degrees Celsius. Some water particles will have enough energy to leave the rest of the particles. This means that the water turns into a gas and is now called steam. So make sure you've got them in the right order, and take note of the temperature at which water will start turning into steam. Something very similar to boiling, but slightly different, is evaporation. Evaporation is when the particles on the surface of a liquid gain enough energy to escape as gases, but not throughout the entire liquid substance. But my question to you is, how is evaporation useful? It's useful to us in one way, that we use probably every day and don't realise that we're doing it. So have a little think. How is evaporation useful? So evaporation is useful because of sweat. So when we sweat, we actually get water sitting on the surface of our skin. And then the water evaporates. It turns into gas. It needs energy to do this. So the particles have to get that energy from somewhere. And where they take that energy from is from your skin. And that is what cools you down. And that is how sweat actually helps you to cool your body down. Here's another question for you. What is the opposite of boiling? Can you think of an example of it? Give you another hint. If boiling is something going from liquid to gas, what is the opposite of that? And do you know the name of it? Did you say condensation? And if you did, very well done, or condensing. Condensation you have probably seen when you are having a shower, when you've just got out of the shower. Condensation is when the gas particles become liquid particles. It's when they start to decrease in energy and start to form again as liquid. You've probably seen it when you get out of the shower and you've got liquids like drops of water on your mirror or on your shower screen, something like that. That is condensation. Can you write down the definition of condensation in the blue box and then in your own words write down an example? I've got one more change of state to tell you about, and this one is a really cool one. This is called sublimation. And sublimation is the change of state from a solid straight to a gas. This can be really useful, like making stage smoke. So when you see like smoke machines and things like that, it's from something called dry ice. And what happens is, a solid can sometimes undergo the change where it will just give off vapor without melting first into liquid. An element that does this is the element iodine, and you can see that at the bottom there because it gives off this purple vapor. So the change of state when something goes straight from a solid to a gas is known as sublimation. Can you write down the definition for sublimation? It is the change of state from a solid to a gas. Okay, your turn. You do not need to write these down. I just want you to see if you can match these in your head. There are 3 pictures here and there are 3 changes of state above. Can you please match the 3 changes of state to the correct picture and try to say if it shows evaporation, condensation, or sublimation? So the answers that you should have got is that the clothes drying on the line is going from liquid to gas. All that water in the clothes is drying off, liquid to gas, and that is evaporation. The water on the glass there is gas to liquid. It was gas when it was in the air and now it's hit the cold glass and it's become liquid, and that is condensation. And the solid straight to gas is our very cool one, sublimation. Okay, a little bit of drawing time. Get some pencils out, please. Pencils for scientific drawings always. I would like you to draw this diagram first of all, leaving these gaps to label it in a second. So you are going to draw a solid with the particles in a regular formation. Here you can see ice. You're going to draw a liquid in the middle with the particles sliding over one another. And then you're going to draw a gas on the right here with the particles moving freely and colliding with each other. You're then going to draw these arrows on your diagram, just like it's done here. So an arrow going from gas to solid, solid to gas, and the 4 arrows there in the middle. But the most important bit is that you are going to try to label this diagram in the correct places. You've got all the words down there at the side. I'd like you to label your solid, liquid, and gas. but I'd like you to also label the changes of state. So which arrow is showing what? Pause this video because you must have a go at this before it goes on to the next slide. So pause now. Okay, how did you get on with that challenge? This is what your diagram should look like. Solid, liquid and gas goes from left to right. And just make sure that you have got your changes of state in the right place here. There was one that I wanted you to get through process of elimination, because sometimes you will get things on tests and there might be a word that you can't remember, but if you can do everything else first, then you know that the one that's left must be the correct answer. So that word on this one was deposition. It is the opposite of sublimation. So if you got that sublimation goes from solid to gas, then gas straight to solid is known as deposition. So check the diagram and make any corrections that you need to. Okay, well done. This is your last task for this lesson. I would like you to describe and explain what happens to the particles when water boils. We've had a lot of information on this today, but now this is down to you. I'd like this in your own words, please, and I would like a diagram to accompany it. You can do this in any way that you like. You can write out an answer and draw a diagram. You could draw a diagram and label the diagram, or you could do a comic strip style answer where each picture shows a new step of what's happening to the particles. What I would like you to do, please, is to include as many words as you can from the word bank there on the right. I'd love to see how you get on with this, so please do this in your book, and if you are able to send me a picture of your work, that will be absolutely fantastic. Once you've had a good go at that, this is the end of our lesson. Very, very well done today, Year 7. Let's have a look at our learning objectives. Have you used the particle model to explain boiling? If you think you are now better at that than you were at the start of the lesson, give yourself a new progress mark. Is it red, amber or green? Can you now state the temperature at which water boils? And can you identify other changes of state? Going to finish with a choose your science joke. Tell me, how do astronomers organise a party? They plan it. Ah, very cheesy. Very, very well done, Year 7. Really, really pleased with you for doing the work at home and for logging on to all of our lessons.